Hey guys, welcome to my another video. Today's video is going to be about a circle mill. I did cover that subject on my other channel. We're going to go into a little bit deeply and talk about what you can actually do with this option. So right now, and how easy actually it is to do it. So right now I'm doing a part like this. And we're doing this with circle mill. So what circle mill is good about, you can do counterbores. Let's say if you sometimes would do drill on top instead of center drill, you can actually do a little bit flat with the circle mill. So counterbores, flats, and whatnot, and yeah, and then you can drill so you have some flat surface. Let's see what are we working on and explain the program. So this is a part. So as you see, the circle, center of the circle is 1 inch from the edge. This is a 2-inch part, so half of the part is 1 inch. Pretty simple. And the whole circle is 1 inch and 620 thousandths. Okay. So this circle mill is going to be done on a ZOI. And actually, let's even start with. Let me pick a program and show you where it can be found. Okay, so program added. We're gonna add a line. We go to point machining, and on point machining, it shows you a circle mill. Okay, so this is where your circle mill can be found. So now let's go back to our program. And explain what's where, and you see how easy it is. So the circle mill, because it's done, because it's done over here on top of the cylinder, so that means it's gonna be on a Z and then a Y, because the turret drops up and down, so it does it in a circle motion, and I'm gonna show you later. Actually, let me show you now. See if because it's doing it now. So this is it's literally like a tornado. So you should see it lowers itself on a Y. And Z, and then it drops a little bit on X. Let me see if I can show you a toolpath. Path to raise. So this is the part. So if I'll go, pretty much see. So it rotates. So that's how circle mill works on the tornado option. Okay, and close the door. Gonna turn on the coolant. Okay, so circle mill mode is gonna be a ZY axis, position C, so this one's gonna be a 0. It doesn't have to be an angle to anything. The option is a tornado. Diameter of the hole, it's 1.62. Like you see on the drawing. Fairly simple, right? The depth, so the depth is gonna show from the top of the part how deep you wanna go. So sometimes, let's say on some of the mills, if this would be a 1 inch, you would have to start from 5/8, and she knows to start 3/8 or 3/75 a little bit higher, right? This one is you actually give the machine diameter. So in that, this particular situation, the diameter will be 1 inch because it's half of the part. From 1 inch, she knows to go 375 thousandths deep. We have no chamfer. The bottom, that's just going to be a finish. It's going to be 5, and then pitch. We have 2 pitches. So the pitch means she's going to take 30,000 depth of cut, each time she's gonna go lower and lower, okay? So that's what pitch is. And then obviously end mill out, this is a 620, so it's a 5/8 end mill. The whole size that's automatically applied. We have over here, hold depth, that's gonna be 1 inch because it's a 1 inch diameter. Screw diameter, nothing, counterclockwise and such. Then your speeds and your feeds and your coolant over here. Now the figure. So this is a point machining. Starting point Z, it's 1 because the center from here to here, we already know it's 1 plus minus 30. So starting point Y is going to be a 0. Starting point on radius, that's 1 because like I said, we already figured out that this is going to be a 1 inch from the center. And then pretty much the P is 0 and R is 0. And so fairly easy to do a circummill. Now let's, you can actually also do thread milling. You could do thread milling, let's say, you know, from the top. You can do thread milling from the face and whatnot. Let me see the part. So if you would want to actually thread, you know, this hole, you can actually do it with this option. And let me show you how you do a thread mill. I do have a program. Let's say, so give you an example. 481. Okay. So the option is thread milling, but you actually can, you know, it's not designed to be threading, but it does. It actually does a really good job doing that. Okay. So the thread milling, this is a thread milling regular on a face. So it's still called circummill. It's now, instead of Z and Y, it's going to be an XY because it's an edge mill, so it goes not on top, it goes inside through the face. And then position C at 0, tornado, diameter. So this is the diameter of the thread. Okay, so let's say if it's a 1 inch thread, your diameter it would be 1 inch. Inside, the depth is going to be 1 inch and 20,000. Chamfer 0, and this is important. The BTM, the bottom has to be 0. Okay, so when it's threading and it's doing the swirl, she doesn't go all the way to the center and bottom out on you. And then your pitch 1 is 0, and then pitch 2 is going to be your actually pitch of the thread. So this is number 5 thread, so the pitch is 0.2. If you had, let's say, number 8 thread, the pitch will be 125,000, right? And you cannot tell her that this is a, let's say, a thread mill. You actually have to call it an end mill. So my end mill diameter on outside, my thread mill on outside was actually 620. So I'm telling her this is an end mill that's a 620. So she knows the diameter is 620. Now this is a whole diameter, it's 940. The depth, so that's copying from the top. And remember, one is for the tracing, the other one is for actual part, for machining part. So whole depth 120. This is a clockwise, and then you have a rough 5, speed 140. Okay, feed rate 5,000, and coolant is its own. Now we have a point machining. Starting point R is 0. Starting point C is 0. Starting point Z is 0. All zeros across the edge. Now, here's the deal. So this is this thread is for 1 inch times 5. So 1 inch and 5 threads per square inch. So it's a pretty thick thread. So I did it in 2 passes. So when you look at the 2 units, they're actually identical, except when you look at it. See, for 1 inch Acme thread, the diameter, the finished diameter is actually 1 inch 30,000. So over here I did 940. Over here I did 1 inch and 30,000. That means I did roughing pass, and this is a finishing pass. So I didn't want to go all the way, you know, to 1 inch and 30,000 on just one pass. So that's why you see 940 to 130. This is the depth is the same. Everything is gonna be the same, the pitch and whatnot. And the only difference is gonna be, like I said, it's gonna be the diameter, okay? And remember, the diameter has to match this one and this one, because if you change this one and you're not gonna change this one, nothing's gonna change, okay? So both of them have to be equally adjusted. If let's say you have a really big thread or you have a smaller thread, then you can do it one pass. If you want, you can do it in 3 passes. So you can, let's say, you know, break this down into like 3 sections. But like I said, like your points and like I said, because you know your R is gonna be 0, your C is gonna be 0, you're starting from 0, so it's all zeros across the page. The only thing that matters is the tornado, the finished diameter, so 940 then 130. The depth is gonna be the same thing, unless you wanna leave some stack on the depth for some reason. And this BTM, it has to be 0. Okay, this is very important. And then pitch 1 is 0, and the pitch 2 is gonna be the pitch of your thread. So that's how you write a program with the threadmill. And let me restart this cycle. Let me see. And you see how the machine behaves on the threadmill. A little bit better. Always try to give yourself a little room if you thread or does anything. I'll show you one more time what she does. So the first time when I did it, I went a little bit higher, and so she wouldn't actually hit the part. For some reason, sometimes she gets a little crazy. Let me see. I got a home in the wire. Okay. Memory single. Okay. So we run it, slow it down a little bit, and look how she acts. Okay. See, she doesn't go to, so she goes to the center, then she moves all the way to the end, and then she starts to do the circle. So if you would actually, let's say if you do mess up, and just like that, just look at the position. Now the position of the axe is actually a little bit different, because the position on the axe is going to be different if your Y is under or higher. Okay, but give yourself a room. Like, so when she starts, what I would do, I would change my let's say bring the tool, you know, next to it, and once she starts cutting, then I would bring it above the part and see if she clears. If let's say if she wouldn't clear, then I would just let's say start a little bit higher. But sometimes, yeah, when she comes to the part, she goes straight. Sometimes, you know, the machine actually goes down, goes up, and then starts to cut. So always be careful. Always give yourself some room, and hopefully this is gonna help somebody with your future jobs. But this is a fairly easy option on the Mazak tool to use, and I love it. I use it a lot, and like I said, it's pretty straightforward. Thank you for watching, and see you next time.